All right, so before we jump into things, I just want to kind of go over what the expectation is for what you have in place by the end of this video. So what we're going to look at are the differences between CAD and BIM, what the two of those things are, and why we would want to use one over the other, and how kind of BIM has come into play. Some of the benefits that BIM brings to the architecture, engineering, construction community, and as well as how it comes into play, particularly within the software Revit, which is what we're going to use for the remainder of this course. The other things that we're going to make sure that we know by the end of this lesson or this video is that you have come up with a game plan for how you're going to access Revit as an Appalachian student. And then we're going to actually open up Revit and we're going to play around within one of the sample files for just looking at the interface and navigation. And then finally, I'm going to go over what your final sorts of Revit assignments are going to be. We are going to be doing kind of a two-part assignment. One house that we are going to build together with each other in class, and then you are going to choose another house from a list that you are going to build for homework. So these two assignments are going to have a lot of similarities to each other, but they're going to be actually recreating two different houses. And so at the end of this course, you're going to have 3 Revit models made and finished that you could potentially add to a portfolio. And there's actually, I believe, 5 assignments in total that you could do when it comes to adding extra credit on as well to just kind of build these skills. Because much like AutoCAD, the only way to get really good with Revit is just to use it a lot and often. So just to get started with a little bit of an introduction is we have worked with CAD for the last about 5 weeks. We took a little pivot into SketchUp, but what CAD stands for is computer aided drafting. Some people call it computer aided design, but I really try to stray away from that purely because in CAD, we really aren't doing a lot of the design work or the modeling work. To me, these two words really signify having some creativity involved and testing out different theories or testing out different ideas. And the sort of rigidity of AutoCAD doesn't lend itself too well to that. Because AutoCAD, as I've mentioned before, is a little bit of a dumb software, for lack of a better term. So in the aspect of these 3 interior kitchen elevations where it's showing the cabinetry, AutoCAD has no idea what's going on here. It just knows that there's this big square here and then a small rectangle here with another small rectangle in it and another small rectangle in that. It has no idea that that's a cabinet. It just sees it as a series of lines and rectangles with some different colors set to it, but it doesn't really have any idea what's going on. So nothing in this model, nothing in this drawing is related to each other. It's only related in the terms of you, the designer or the engineer who's put this together in the software. You understand how these 3 drawings would relate, but the software itself doesn't. What also makes that a little bit difficult to work with as a designer is then if one part of the project changes, you, the drafter in AutoCAD, have to go into each drawing and revisit it. So if my client decides that they actually want a different facade up here for the hood of this part with the oven and stove, I have to then go and change it in this view and then also go change it in the floor plan and potentially then go change it in any structural plans if there's going to be a change to that there. Or if they've decided that they want a smaller kitchen and so they want to make this 5 feet smaller, I have to not only just adjust the overall length of this wall, but then I have to rearrange all of the cabinets in this wall. It would also then have an effect on this one here, depending on how exactly this 4-wall room that would be coming together. I'd have to change the floor plans. I'd have to potentially change a foundation plan, elevations. All of those drawings that are linked to each other in my mind now have to get manually changed in this drawing, and it just makes it potential or makes a good potentially makes it so that way things are going to get out of sync and I make a mistake in there. Now, what BIM stands for is Building Information Modeling. Every piece of the building in your BIM model has a lot of information attached to it or tagged to it. So BIM is smarter than AutoCAD in that BIM recognizes you are making a building, and therefore it knows your building is going to be compromised of walls, windows, doors, and the like. And it's then going to have information tagged into those pieces so that way you can kind of model a little bit faster. So when I have a wall, I can also define how thick the wall is. I can define the materials in that wall, the R value of that wall. All of those bits of information can be assigned within that component or within that parameter related to the wall. And furthermore, there's going to be information about the relationship between the different views as well as the relationship between the components. So for instance, when we go to place a door, BIM software is aware that a door needs to be put inside of a wall, and therefore it will only let you put that door within a wall or something like that. And the best part is that BIM is understanding a lot of those standards related to how sets of documents come together. So when I create my floor plan and I put in all of the different parameters related to my walls, so I put in, excuse me, I put in my length and I put in my height. What's also going to happen is that it's going to create my elevations for me as I'm going through. And any change I make in the floor plan, if that change appears in the elevation, it'll update in there too, which is really wonderful and nice. And we'll start to see that with Revit. Then industry-wise, one of the big benefits of BIM is what we call a 6D software. And there are even some people who relate BIM to 7D or 8D, but we're really only going to kind of approach it within this 6D amount. And even then, so much so, we're not really going to focus a whole lot on the 4D. But what we mean with those 6 dimensions of this project is the first thing BIM covers is just the 3-dimensional geometry of a building. So I'll be able to see and understand the building on an X, a Y, and a Z relationship between each other. But what BIM can also track is a 4th dimension, which we call time. So within all of those different elements and parameters, I can start tagging things and I can relate them to a time frame of when certain pieces will be installed, or when the concrete will be poured, and then when the concrete will be set. When can I start construction on the actual floor frame? When are my windows set to arrive on a site so that way they can be installed? So if all of those things are tagged with that information, I then, as a project manager, would be able to track the timeline of how long this building will take to be erected. And I can do it pretty accurately if I am using the parameters wisely in the software. But we are not really going to focus a whole lot on this one. The 5th dimension we can add into our parameters is also money. So we then can estimate how much concrete we need to purchase in order to pour our foundation, and therefore we can now know how much money we need to spend on the foundation. We can also tag money into all of the different materials within our walls or the different components we're buying, the windows, the doors. And so I can get a cost estimate for how much the building's going to cost in general. And I can also do a little bit of a cost estimate for things related to how much money is it going to cost to operate this building. So, whoops, sorry about that. So here is just a little visual preview of something that BIM can do pretty well, in which it's estimating how much sunlight and how much heat is being impacted on the various windows of this facade. And so through our ability of figuring out the R value of all of our materials, we then can get a lot of information about heat transfer. We can put in our HVAC system within a building, and then we can estimate how much money we'll need to spend to heat and cool the building on any given work day. because we can also tag a geographical location to a building, and we can get that pretty accurate. So we will spend a little time here in this money area, as well as then the 6 dimension sustainability. We'll spend some time in there too. So as I mentioned, we can then tag a specific geographical location, and then we can know exactly how the sun's going to come into effect to a building, whether that's through shadows or whether that's through natural light. We also then can put solar panels on that site and see how much energy a site will be producing on any given day. As an estimate, it's not going to be a trillion% accurate, but we can still estimate that pretty well. And we can also look into a life cycle of the materials we're using. Because again, every material, as soon as we make that building, is going to start breaking down. It's going to be a fairly slow process of breaking down, so that way our building can last for many, many, many years. But eventually, the plastics and the adhesives that we're using, as the sun is just sitting and hitting them, they'll start to slowly decompose. Our concrete, as it takes in water, releases water, takes in water, releases water, will slowly start to erode. These are just the natural things that are going to happen. And we can look kind of at the life cycle of that, as well as potentially, even with some plugins, look at a life cycle of like the production of a piece of steel and how much that's going to come into play with a building. And so that's pretty cool. We're only going to scratch the surface of some of these things. And really within Revit in general, because we only have these 5.5 weeks with it, we're not going to be able to dive into every single small nook and cranny, but I'm going to try to give you guys as much as possible, so that way when you leave this class, you can feel comfortable either searching for other things or playing around with some of the features that we maybe didn't cover in class. So the software that we're going to focus on is called Revit. Revit allows us to model the entire building or the entire structure as just one single piece. So instead of having just our various views around model space, or even having just different files in AutoCAD, we just have one singular file of a 3-dimensional model of the building, and it's going to compose those different construction document views for us. Revit is still a sort of newish software. It's no longer really considered all too new. But when I was in college, this was really like a brand new thing, and it looked very different than what it looks like now. So Autodesk acquired this software in 2002, and then it really started gaining a lot of popularity and traction in around 2008 is when people started using it a lot more heavily. Every year they release a new version with updates and features and fixes. And I've mentioned how, AutoCAD, every year there's a new AutoCAD version released, but there haven't really been changes made to it in it's been probably about 10 or 12 years since there's been like a big change between the software. Well, in Revit, there are pretty significant changes and things added. Sometimes the things that are added really don't have an effect on like me as someone who uses it primarily as just a design and modeling software for just architectural concepts. But there are sometimes fixes then that are going to make a huge play for someone who's like a structural engineer or a mechanical engineer in there. So within the software, all of our views are linked in here. So on this little setup, and we'll look at the screen in a little bit more detail later in this presentation, we have all of these different views though in what we call our project browser, that we can just go between our floor plans and our elevations, and anything that gets changed in one view also gets modified or updated in another view. So if I make a change in my floor plan, and that change gets made in my elevation as well, or if it's something that would appear in a section, it would get changed in there too. So we have this ability to just kind of design a little bit more freely without having to worry about making any of the updates to it. Another huge benefit of Revit is its rendering capabilities. So Revit does have its own own render kind of platform within the software. However, it's not all too amazing. We actually have a plugin that's installed on all of the desktops that does it a little bit better. But what these renders do is they create our perspective style views. We can do a 1-point or a 2-point. So this picture here from this screenshot is a 2-point perspective because we can see here all of these edges are going to converge towards a vanishing point. And then on this side, we're converging towards this vanishing point. So it's going to create a realistic looking drawing. We can apply our material textures to that to then make that even more realistic. And we can even then put in some different site components or different backgrounds to kind of help sell an idea to a client, or even just kind of visualize it ourselves a little bit, since it is going to be a building that is make-believe that we are trying to hopefully potentially sell. The final kind of selling point for Revit too is its collaborative capabilities. So there is the option where multiple people can work within the same file at once. So if I am on a shared network with someone else, meaning that we're on the same internet, and potentially Ethernet is how I've known it to work, but it could now be that it can work through the cloud, is that I can kind of sign out this first floor and I can work on the first floor while then someone else in the office is working on designing things related to the second floor. So that way we can get the work done a little bit faster and we don't have to wait for one person to finish. So that way the other person can start their portion of the job. From what I know, and again, it could have changed since then, there aren't too many ways to use the collaboration features as an education student, especially because we do not have access to the Autodesk Cloud through education accounts. And also, if we are not operating on the same network, again, so like through the same Ethernet cable and we're both connected into the same data points and we are able to put the file onto a shared drive. If I can't do that, then I don't know how I'd be able to work on the file simultaneously. So that's sort of something that we're not going to explore in this course purely because I don't believe we have the ability to, nor do we have the time. But it is there and it's something that can be done. So before we jump into looking at Revit and playing around with Revit, one thing I want to make clear is that Revit is a Windows-only software. You cannot install Revit on a Mac. It only is available for Windows. So there are a few different ways you can potentially access the software. One is if you have a Windows computer, you can download a student version of it. So I have it linked here in the presentation, as well as, oh, I thought I put it in here, but I didn't. So I'll add in a little thing here for a student download for the Autodesk website. But if you just go to the Autodesk education website or just Google search Autodesk student download, you'll be able to sign in. It'll be the same account that you use to make an AutoCAD download AutoCAD as a student, and then you want Revit. You do not need Revit Generative Design, so do not download this one. This is the one you need. Revit will take a fair chunk of your storage. So I believe right now with all of my plugins and my content library, Revit is taken up, let me see if we can even just use it or look at it. For my apps here, and I just have it sort by size. So Revit is taking up 13 gigabytes of storage on my computer. And then too, I also have the content library here, which is taking up an additional 3. And then I have a few plugins that I personally like that are then taking up a little bit more space. So all in all, I would budget for having about 18 to 20 gigabytes of storage of your computer is going to be taken up by Revit, which I do understand in some cases that's a lot. But you can download your own copy on a Windows computer right here through the Autodesk website. You will need to have at least an i7 processor or whatever the AMD equivalent of that is, which I'm not sure, but if you have a computer that has an AMD in it, you could do a quick Google search to figure that out. And then 8 gigabytes of RAM is what they say for the minimum. I would recommend having 16 gigabytes of RAM. And these are also just kind of some insights for if you are going to be purchasing a computer after this course or after graduation, just to think about what you have that computer for and what you're going to need it to do, and just make sure that it's meeting at least these equivalents. If you're unsure if your Windows computer has like what type of processor you have or how much RAM you have, there's usually a little sticker in the bottom corner of your keyboard that tells you if it's an i7 or an i9 or a Xeon or an Xeon. I don't know how to pronounce that. But another thing you could do is on the search bar, if you search for about your PC, it's going to bring up with the processor that you have as well as how much RAM that you have. So if you have less than 8 gigabytes of RAM, I do not recommend you install Revit on your laptop, even if it is a Windows one. Another way that you can access Revit outside of class is through Udesk. And so I have a link to Udesk. And then I also have a link here for Autodesk Student Access. But I have a link to Udesk right up here at the top of the page, and I also have it linked in the presentation. But what Udesk is, it's a virtual laptop or virtual browser. So what it's going to do is log you in on the computer through Chrome. So if you come here to log into Udesk, it will ask you to log in with your AppState email. And so I'm already logged in here. And then you are going to have access to a specific computer, which is this Applied Design and Sustainable Tech Built Environment GPU. So if I click on that one and I just say allow for resources, it's going to ask me to log in with my AppState email and password. And this will log me on virtually onto one of the Computer Lab desktops. So this is one way then that I'll be able to access Revit, even if I'm on a laptop that maybe just doesn't have enough RAM installed on it, or if I'm on a Chromebook, or if I have a Mac and that's all I have access to, is this will log me in virtually onto a computer as if I was just sitting in the computer lab. This Udesk can sometimes be a little slow, as a warning. The other thing I recommend doing is saving your work pretty often and then also emailing yourself backups. The weird thing though, when you're emailing yourself backups, is even though right now I'm in Chrome, I would want to virtually go into Chrome here in this desktop, log into my email, and send myself a file. If you save anything on the desktop in here, it is not going to be here the next time you log in. So that's why I recommend either plugging in a flash drive and saving to there, or going through this weird version of going on the internet, even though you're already on the internet, and emailing yourself a file to make sure you have everything and you've saved it. So Udesk is another option that you have here. And then finally, you can also use the computers in Catherine Harper Hall. So what I have linked here in the presentation is just when the computer labs are available. So room 40 is in the basement of Catherine Harper Hall, or the ground floor. And there are a few openings throughout the day in which you can use that room. Any time here is obviously when there's a class, so please do not go in there. Or all day Friday. If the room is locked, then you can just go to the front office and ask someone to unlock it for you. Our classroom 207 is used a lot during the day. However, it's open in the evenings. Our tutors will still be here on Tuesdays, Wednesdays, and Thursdays, available to help with any Revit help that you might need. And then, of course, all day Friday, the room is available too, as well as Saturdays and Sundays. If the building is locked, you can get into Catherine Harper Hall using your app card and the little swiper on the front door. And the code for this classroom here, 207, is 20720 star. And there's also in room 205B, which is kind of diagonal across from our classroom 207, there are 4 desktop computers in there that have all of the software installed, and there's a little bit more availability in that room. So if you're really in a pinch and you want to use one of the desktops, there's some times within there too that you can get into 205B to access a computer. So there are 3 ways that you can access Revit outside of class time. You can download your student copy on a Windows computer only. You can go through UDesk, or you can go and use a computer lab during a time that we don't have class. So what I want to make sure you all have is, but by the time you close out of this video, you know which one of these 3 you're going to use in order to get the homework portions of our Revit assignment done. Because for some of you, particularly if you have a Mac, you're going to need to come up with some type of game plan of using UDesk or the computer labs. Additionally, if you're going to download a copy of Revit onto your laptop, your personal laptop, after you install Revit, you will also need to click on this link to install the component library. So once you download this and wait for it to finish downloading, and then you can click on it and run the installation to get the component library. If you're using UDesk or one of the computers in Catherine Harper, you obviously do not need to do that. Okay, so now before we go into actual Revit, I just want to kind of look at the start screen and just some of the little features on here. So when you first launch Revit, this is a start screen that you'll see. It'll have the projects you've worked on recently, as well as then a few samples. Since this is the first time you are opening Revit, you're only going to see just some samples, and we'll even explore this sample one in this video today. But this is basically the same as the start screen for AutoCAD, where it's just going to have your recent projects. And then we have 2 different categories here. We have models and we have families. So models these are going to be like our building projects, our architecture projects. Families are the different things that go into our projects. So you can even see here that I have some families that I've opened up. So I've got a family related to a light switch, a family related to a single flush door, a family of a washer dryer stack, a window tag, a title block, and then this was a column too that I even went and downloaded off the internet. So these are just different components or different things we can put in our project, versus models are the projects themselves. And whenever I want to start something new, I would just want to click on that. I would want to make a new model. Then once I'm in my project, my workspace or my user interface is going to look something like this. There are a few different ways you can set this up, but the way I have it right now is the default way that things pop up, and it's kind of the preferred way I like working with a lot of things. So I have my main just viewing area or drawing area here. It's going to vary based on if I'm in a 3D view or if I'm in a floor plan or if I'm in an elevation. Things will look a little different, but this is just my basic drawing area. And then I have my 2 main ways of changing things or changing what I'm looking over here. So this little green box is what we call the properties bar. And the properties bar is going to give me options related to whatever object I currently have selected. So at the moment in this screenshot, I have nothing selected. So it's giving me options about the 3-dimensional view I'm looking at. So it has information about like the detail level, what's visible, if I want grids being shown, if I want the sun being shown, if I want to start cropping things. So I can play around with some of the different options here in the properties bar based on whatever I have selected. Underneath it, this purple area is what we call the project browser. And the project browser is one of the ways that we switch between our views. So if I double clicked on level 1, it would bring me to the level 1 floor plan. If I double clicked on level 2, it would bring me to the level 2 floor plan, versus if I double clicked here, it would bring me to my ceiling plan for level 1 because it's under the ceiling plan area. And I have additionally my elevations, and I also have sheets here. So this is kind of like Revit's version of Paperspace, where I can then start to set up pieces of paper with my scaled views and crop everything out of it. So this is the main way we navigate between our different views within our model. And then this is how we change different settings related to the pieces of our model. Now, within our toolbar up at the top, the main area we're going to model a lot of our stuff in, which, whoops, I accidentally clicked, is right up in here in this build area. So this is where we can do things like place walls, place doors, place windows, and the like. We can see too that we've got different ribbons up here that we'll explore a few of them in the class as well. But this is where we're going to do most of our things, and most of the tools are pretty straightforward. So if I click on the window tool, it's going to start placing a window, and then in my properties bar, I'll have some options related to that window. Or if I click on column, it'll start placing columns, and then again in my properties bar, I'll have options related to that column. The option here is always going to be different based on what I have selected, because the options of how I'm going to construct a wall would be pretty different than the options for how a window is going to be placed. So the information here is going to vary based on whatever I have selected. Up at the very tippy top here, this blue area is what we call our quick access toolbar. And so this is how we can save our project. Revit is also going to give you save reminders about every 15 or so minutes. A little pop-up will come in Revit and it'll say, you haven't saved in a while. Do you want to save? Which is fantastic, so that way we don't lose our work. But this is where we can do things like save. We can also take some measurements really fast, and we can also switch to our 3D view very quickly. And then we can turn on a setting related to our line visibility. So our quick toolbar has a couple of different options in here that we'll play around with and look at. At the bottom of the screen down here is what I refer to as our status bar. And so our status bar has some features related to our visibility and how things appear in a particular view. So it has things like our detail level, if it's something is going to be in color or realistic or just black and white, if we have the sun and shadows turned on, if we are hiding different things or features, cropping our view. So we have some features down here that are related to our visibility, as well as then our scale is down here as well. And then the last thing I just want to mention on the user interface is we have our view cube up here, which is one way that we can orbit around within our drawing or within our model. So I was able to change my screen to this new screenshot through a couple of different things. One thing I did was I double clicked on my floor plan to bring myself to the level 1 floor plan, which then changed my view from this 3D model of the building into the floor plan. And then my properties bar has changed because I clicked on this window here. So it's blue because I've selected it. And so now I have different information related to this window. So I can see that it is a double hung window. It's 24 inches wide by 42 inches tall. I have information related to its sill height. So that's how high is the bottom sitting above the top of the floor. And I can even then change things related to what's going to be visible in this particular plan graphics wise. So I can get a lot of information related to this window right here through the property bar, simply just by selecting it. And I can make adjustments through the properties bar after I select it. Currently, my scale for this floor plan is also set to 1/8 of an inch equals a foot, and I have my detail level set to coarse. So this is going to affect on how large symbols like my staircase leading upward or any dimensions I have. It's going to affect how they appear in here, as well as then how much detail is shown. So with my detail set to coarse, I'm just seeing the thickness of this wall. But if I set it to fine, I would be able to see things like every single layer, the drywall, the stud, the sheathing, the siding, all of those things would become visible. Additionally, in this view, I also have this feature here turned on called thin lines. So that's why no line weights are visible. So we'll explore some of this in just a bit when we open up the software to look around. Finally, we can also see too that from just my original toolbar, I've been placed into this modify toolbar because I've clicked on a window and it's asking me then to do some modifications related to it. So this is where I could start to play around with moving things, copying, rotating, offset. I have some mirror tools in here as well. I have some trim and extending tools in here, as well as this align feature. Some of these work a little bit different than they do in AutoCAD, purely because, again, this is a comprehensive 3D model where AutoCAD was just a series of lines and rectangles, and it didn't really know what it was making. Revit is smarter and it knows what it's making. So especially, I can just kind of drag this window around up and down here to move it, but I don't really have the ability to rotate this window 360 degrees because this window has to stay seated in this wall. I can flip it in and out, but I can't rotate it around and things like that. Now, to navigate through Revit and how you're going to use everything in the software, we have the toolbars up at the top, and that's where we're going to spend the majority of our time using the tools, particularly because every shortcut in Revit is a series of 2 letters. So if I wanted to create a wall using keyboard shortcuts, I wouldn't just type W, I'd have to do WA to make a wall. And then door, I believe, is DR, but it could be DO. I could be mistaken about that. So I rely pretty heavily on the toolbar buttons in order to just kind of make everything that I need to do with a few keyboard shortcuts. Anytime you are unsure about a tool, if you hover over it in Revit, it'll give you a little preview of text of what exactly that tool does. And if you continue hovering over it, it'll even give you a little video demo of what exactly that tool does. Another important thing with navigating Revit is when you click on elements, you get information related to it. So in this case, if I've clicked on a wall, it's telling me that it's a generic 8-inch wall. I could also click here to switch my wall type, and then I can have specific information such as what's the bottom of this wall, what's the top of this wall, and what is its structural use and things like that. So I can play around with some of the properties in there. There are a few different ways to change views that we'll go over too. So there'll be some tabs up at the top that we can move between, as well as the project browser, which is my favorite way. And then our navigation is opposite of SketchUp. So if I just click and hold the scroll wheel, I'll be able to pan around in my drawing. If I hold the shift key and the scroll wheel, I can orbit around in my drawing. Now, if I'm in a particular, if I have something selected, like my window here, and in the properties bar, I click on this edit type, or if I had this wall selected and I clicked on edit type, it's then going to bring me into this parameter menu with all of the different properties. So we can see here then that I have so many different options that I could customize within this window. So I can even customize how the exterior frame is going to sit. I can customize its rough width and its height. So if when I'm going through my different window types, I can't find one that is the exact window I want, I can make my own custom one in here, or I could even go find one online and I can download it, similar to the way CAD Blocks works. This window here can seem really overwhelming, but there's a lot of things in here that we never really have to touch. And we're going to explore that in about a week or so. I just want to have you aware that it's something here that we could potentially use and work with. And one of the final cool things, or the second to final cool thing that Revit can do here, is play around with some of its rendering features. So within a render, this again is when we can take our 3D model and we can make it into a realistic image, which I then can put into Illustrator or Photoshop and further manipulate. Unfortunately, these things got moved a little bit within my presentation. Well, that should really be there, and that should be there. There we go. We can pretend that they were there the whole time. So within the View tab, there's this option to render in-house within Revit. But you'll see then on the lab computers, we have this add-in called Enscape, which is a little rendering extension that does a fantastic job that we'll play around in class. And if you want to put Enscape on your laptop, you can, from their website, download a student copy for free. And I have a link to on the course webpage for Enscape here, which will take you to the educational license page. You do just have to tell them that you are a student. You will also notice here that they do have Mac, because Enscape can also be used in software like SketchUp. So if you wanted to do renderings from SketchUp, you can do that as well. Finally, there's also then a benefit of Revit through its exporting capabilities. So what you may find throughout internships or just kind of your first job starting out is that some people are using Revit and some people are still using AutoCAD. And so Revit, being made by the same company as AutoCAD, has this ability to export things pretty easily to the DWG AutoCAD file, as well as what's called a DXF, which is an exchangeable file type, which means then we can put this into software like Illustrator to further manipulate it from there. What can be beneficial with this DWG is, especially when we are getting things ready for wanting to like laser cut a model, an architectural model out. So I could export the individual walls or the individual faces of my model and then prep that and get it ready for the laser cutter, which is something that we're going to explore towards the end of this course and play around with the laser a little bit. So now that I've talked on Revit and I've shown you some screenshots of it, what I'd like for you to do is, along with me, kind of open up Revit yourself, whether it's on a desktop computer in the lab or on your laptop, and we're just going to play around with one of the sample files. So what you can do for that is, just on the desktop, there will be a little Revit icon on the lab computers, as well as through UDesk. And I'm just going to launch Revit. Let me just check how long I've been talking here. 43 minutes. Okay. And so again, when you first launch Revit, it's going to give you just all of the things you've been working on recently. And what I want to just kind of open up and explore with you guys a little bit is this sample project. So we're just going to play around in this sample project. We can delete things and we can move things around, because again, we're just going to only use today just to play around with the software a little bit. And so I'm just going to open up this sample project by clicking on it. I'll wait for it to load. And we can see here that what it brought me into initially is a Paperspace interface. So this is a sheet that they've set up with a couple of different renderings of this project, as well as just an index of some of the different areas that they have in here. What they've done in this sample project is they've put a couple of these hyperlinks in here. So that way, if you're curious about this, you can click on that question mark. And this is how to create a 3-dimensional section view rendering. And what they've done there is then, if I click on here, and click here, it will launch to a help page in which it says how to change the extents of this view, and it goes over kind of how to create like a three-dimensional section. I'm just going to go back into Revit. Some of these links are not wonderful. They're definitely not bad at all, so they're pretty helpful, but some of them just aren't great. But what I can do is just zoom in and out with my scroll wheel, and you will notice too when you're zooming in and out that if I move my scroll wheel over here, it's going to zoom in on the word Autodesk, versus if I scroll here, it's going to zoom in on that beetle. It follows your scroll wheel around wherever your mouse is. If I want to pan to move things, I'm just going to hold the scroll wheel like a button, and then it'll move the move my little interface around. The easiest way to get to looking at this model as a 3D piece is right up here in my quick access bar. I'm just going to click on that little 3D house, and it's going to display my model three-dimensionally. So again, I can hold my scroll wheel to move. I can zoom in and out by just scrolling in and out, and it'll zoom based on wherever my cursor is. If I want to orbit around three-dimensionally, I'll hold the Shift key on my keyboard and press the scroll wheel down as if to pan, and then that will orbit me around. Again, that's hold the Shift key and hold the scroll wheel button down, and you can pan yourself around. You can also move around using the view cube here in the 3D view. So I can click on specific views that I might want to just set it to. If I want to just look at it directly from the top, I can just set it to top. You can also hold the view cube. So if I click and hold on the view cube, I can kind of pivot myself around. But I prefer holding Shift and holding the scroll wheel to orbit. So now I'm in my 3D view. So I can see up here that it says 3D, and also in my project browser here, the 3D one is bold. And if I double click on any of these views from my project browser, if I double click on level 1, it'll bring me into the level 1 floor plan view. And if I scroll down in here and I double click on the east, it brings me into the east elevation. What this has done is, as I'm opening these views, it's just making new tabs related to the views that I've opened in this current session. And I can just kind of go through them, and I can make changes in any of these views, and it would update in all of them. So one thing I'm going to do, just to even kind of highlight this a little bit, is I'll open up my south elevation too, is I'm going to go into my view tab, and I'm going to change how my views look. So at the moment I'm in tabbing, my views are tabbed, and I'm going to ask it to tile my views. And what that has done is it's made all of these views visible. So I have my south elevation, I have my east. I'm going to close out of that title sheet. I'll just move kind of around so we can just see some of these all in action here. So I've got my level 1 floor plan, I've got my south view, I've got my east view, I have my 3D. When I talk about the fact that, any change I make in one view is going to get updated in the others, it's because everything is linked. So if I click on this glass wall here, this curtain wall, we can see that it got highlighted here in the 3D view as well. If I decide that I want to change this wall, and I click here and I say that I actually want it to be brick, and I update it, it's going to give me a couple of errors because it's saying, hey, that's weird. But it's brick here, it's now brick here, and also it's brick down here as well. So any change that I make in one of these is going to get updated in all of them. If I decided that I wanted to put a window here too, so I'll go back into my architecture tab, and I'll say I want to put a window, and I just plop a window in here. My window got added into this elevation and also into the 3D model, and it's here in my floor plan. I'll just hit escape a couple of times to get out of it. There we go. If I decided I wanted to move this window, I can click on it in any of these views, and I can drag it along, or my preferred method is to use the arrow keys on my keyboard. And you can see that as I move it in the floor plan, it gets moved in the elevation too. If I do the same thing but in the elevation, I decide that I want to move this window and I drag it in the elevation, it gets moved here or moved here. And if I delete the entire thing, all of those updates gets made. So if I wanted to make changes by just moving this window to just kind of make these spaces even, I can make updates to my drawing in one spot and the entire model gets updated. So I don't have to worry about making changes to each piece. Um, I prefer not to really work though in this tiled view. I just wanted to move into the tiled view so I could show you kind of how changes in one thing are getting updated into the other one. So I'm going to come back into my view tab. I'm going to put myself back into a tabbed view. I just like having a bigger space to work with in my view. And then I can either just change my view up here by just clicking on whatever views I've opened, or by double clicking in my project browser. So I can double click and I can go to my second floor plan. And so when it comes to our views, like our floor plan and our elevations, we cannot orbit around because these are documentation views. This is a two-dimensional view of the floor plan. It's just linked with the 3D model. So I can only pan by just holding my scroll wheel again, or zoom in on an area, hold my scroll wheel to pan. So I only have the ability to just zoom and pan when I'm in this view. Same thing then if I go to an elevation view, I only have the ability to zoom and pan. The only one that I have the ability to orbit around with is if I come up here to my 3D view. That's when I can hold shift and orbit around. But again, all of these views are linked to each other. Lastly, too, another way to go in between views is you can click on some of the symbols related to views. So if I come here and I go into my north elevation, these symbols here on the side, these are our spot elevations for our various heights, but also then for our various levels. So if I double click on that little symbol in my elevation view on the level 1 symbol, it brings me into the level 1 view. If I come here to this symbol, which is telling me about my east elevation, so this is just one way that you can show an east elevation marker, and it's telling me go look at view 3 on sheet A 1-05. If I double click on that, it'll bring me into the east view. I have to double click on the little arrowhead though. If I double click on the symbol itself, it does not bring me into there. But I can also then potentially rename some of these things, which is really cool of how everything gets linked. So for instance, if I go to this sheet 105 here and I right click on it and I rename it, and I actually tell it to be called sheet A333, we can see here, and I know for some reason my thing glitches a little bit with that dash in there. It updated to now have the correct sheet ID. And if I decided to double click on this sheet and renumber the east view, so if I come here to the east and I say that this is actually detail number 55, it updates here on the sheet. And then if I go into my level 1 floor plan, it updates here as well. So when it comes to these symbols, Revit's going to take care of a lot of that kind of formatting for you, which is pretty nice. But that's getting a little too advanced with it. So I don't want to overwhelm you guys too much with it. I just want you guys to kind of look at this sample project, play around with how to move and orbit and open up different views in here. And if you want to, if you're curious about what something is, if I click on this roof, we see here that the properties bar is telling me that what this roof is, where it's starting and stopping. And then if I click on, this wall here, it's then telling me information about this wall and how low it is. Versus even if I click here, it's telling me that this is a female and her name's Yin Yin. Yin Yin's my favorite. So please just kind of look around this sample file, click on stuff, change some stuff around, see what happens. Because just today, I just want you kind of play around with it a little bit. I click on this railing, it tells me a little bit about this railing and how things are associated with it. Lastly, too, of just something that we can look at before we dive into going over what that first project we're going to play around in is we can also adjust how things show up in every different view through our status bar down here. So right now, our detail level is set to medium. My visual style is set to consistent colors, and I have my sun turned off and my shadows turned off. If I just click on shadows, we can turn the shadows on or off. And those shadows are based on the geographical location that the person who designed this sample put. So it's going to be based on a specific time of day, based on my sun path, and then my shadows will come into play. If I want to look at my object, but just see it in black and white, I can switch my visual style here to hidden line. And so that way I can kind of just look at it only in black and white. I can also switch myself over to realistic, which I kind of don't recommend you do too much. I either will operate in the shaded or in the consistent colors, because these are two visual styles for a 3D view that give me some visual cues related to materials, but doesn't take up a whole lot of space on my RAM. Realistic, as we can see through my little spinner, is going to take some processing power. So right now it says it's not responding. If I sit and wait, eventually it will update. There we go. So what Realistic's going to do is it's going to put specific textures for all of the materials in here. And while this is really cool and wonderful looking, this also takes a heck of a lot of power for my computer to operate with. So I don't recommend that you stay in this mode too often. You may want to just switch over to it, see if something looks the way you want it to, and then just go back into shaded or back into consistent colors. But I just don't recommend you spend a whole lot of time in realistic mode. But other than that, today, please just explore this sample file, look around it, orbit around it, and just get a feel for this properties bar and this project browser. So what we're going to do within our first assignment of Revit is going to be, again, as I mentioned, like a two-part project. So I have included on As You Learn here a link to the Appalachian Energy Center, which is a department here on App State's campus. And they have lots of cool resources available through the Energy Center, one of them being the Passive Solar Plan book. And so on this website, there are links to, I believe, 13, we can count them together, 13 different house plans that we can download and recreate or download and use. There is a PDF link here to the entire solar plan book. What is included in this Google Drive link is some pages, about 20 pages of information about what is passive solar and the principles along with it, and how to make sure that you're doing thermal mass storage within things like your floors and your walls. So the first 20 pages are just going over what passive solar entails, and then there are some house plans included. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 different house plans in here. In class together, we are going to do the cardinal. So I'm going to walk you through step by step, and I'll have a series of videos related to this house here called the cardinal. So that's going to be our in-class assignment part, and we'll walk through each day. We'll go over things like adding in our walls, our doors, our windows, our floors, our roof, putting a site around it, all of those different kind of pieces and components to it. For homework, you are going to choose one of the 11 other styles, and you are then going to recreate that for homework. So I am not going to have video tutorials for the other one. However, you can watch the tutorials related to the cardinal and then just make those adjustments for your specific building, because the baby cape looks a lot different than the cardinal. So I'm just going to scroll myself down to page 19, or rather, in total it's page 19 here, but it's page 23 in the actual document. And we're just going to look at what some of these plans are. Many of them are just single stories, and I'll even give some recommendations on which ones are a little bit easier than others. So we have here the Catawba Valley, which is a single story building that has just a little bit of an elevated porch. One thing to keep in mind too with these designs is they are designed as generic buildings without a specific site in mind. So therefore, this house design could be modified for a different site in which the foundation isn't as high, and therefore these porches aren't as steep, or these stairs are not going as steep. So something to keep in mind with designs in a particular area. But this is a single story plan here, in which they are saying that this would be the south side, so that way we can get lots of natural suns through these southern windows here. And then they're giving you some elevations. The Blue Ridge is also a single story plan. So if you are going to feel a little bit uneasy about your Revit skills, I would recommend doing one of the single story ones. This one here is the Cardinal, which is a 2-story house. Again, we are going to do this one together. So you cannot choose this one as your house design for your homework assignment, but we are going to complete this one together. The Baby Cape is one that I do not recommend you choose unless you want to give yourself a big challenge. It's definitely doable because I had a few students do it last semester. But what I would recommend doing is picking one of the other designs, and then if you still want to just really improve your Revit skills, because the best way to improve your Revit skills is to find houses and recreate them, after you do the Cardinal, you do like the Catawba Valley, you do our final project, and then you come back and you do the Baby Cape for another one. Because it's doable, but particularly these roofs and these dormers here provide a little bit of a unique challenge within the software. The garden window is another single story house. It has a little bit of a attached garage to it and some elevations. Bay Breeze is another single story. This one has a little bit of a challenge through this bay window here, but it's definitely a doable challenge even for a beginner. The Sunray is another fairly simple, straightforward 1-story house. It has just one single gable roof going across. Or actually, I might be incorrect. It might have, because it looks like it does have 2. Yeah, so it does have 2 roof pitches, but again, that would be pretty simple, pretty easy to do for a beginner. The Orion has, again, 2 attached or 2 gable roofs, but still a 1-story house, still going to be pretty simple. It might even be modeled as 3 gables since this doesn't go all the way across. We have 2 slightly different heights here, but that would not be a difficult one for a beginner. The Cottage is 1 hip roof. So it's not a gable, it's actually a hip style roof, but in here they've shown it as a gable, which is interesting. But it's a single story floor plan. But I can tell here from these roofs that these elevations are showing a hip roof, not a gable roof. The Hideaway, again, has a little bit of an interesting roof, but not all too complicated to do for a beginner. Another single story. the dogwood, which is another simple single story, and it has two adjoining gables, so we do have a little bit of a valley here, but that's going to be something pretty easy to accomplish as a beginner. And when we go over roofs in class, I'll explain how we could do things like that. And then the last one in the plan book is the mountain laurel. So this is another single story one. It's floor plan. And then it has, again, two gable roofs, just have slightly varying with heights to it. So you're going to pick out of the 11 options, the mountain laurel, the dogwood, the hideaway, the cottage, the Orion, the sunray, the bay breeze, little bit of a challenge here, but nothing too complicated. The garden window, the baby cape, which this would be the most challenging, so I don't recommend this one as a beginner, but you can choose it if you want. You cannot choose the cardinal because we're doing this one in class together. The Blue Ridge, this one is an option for you to be able to choose. The Catawba Valley is also one that you can choose. So take a moment to go through this document here and pick one out. And then, if I go back to the Energy Center website, what they have available here is us to be able to actually download sets of the plans. So I'm going to look at the plans for the cardinal because we'll all need to download these. So I'll click on download plans. And what that's going to do is it's going to bring me to a zip folder that's on Google Drive. And I'm just going to click on download. And then I'll go into this zip folder and I'm going to extract these files. Where these files are going to get extracted, if you want to keep them in your downloads folder, that's fine. I'm going to click on browse and I'm going to put this in my 1728 folder. So that way I have these files here in my 1728 folder where I save my stuff. And what that is done is if I come in here and I go into that folder, is it's given me quite a few documents. I've got pictures of the floor plan. I've got pictures of the elevations. I have a PDF file of just printouts of the plans, as well as then some options related to, how the roof could be installed, and then options related to my foundation, because I could have a slab foundation. I could have a slab with a concrete wall, though, of CMUs. Or I could also then have a brick veneer sitting outside my slab foundation. They've given me a couple of options here with the cardinal. But the file that's super helpful from this download is I actually am getting an AutoCAD file of these plans. And then we can use that to help us recreate this building in Revit. So let me just close out of that. And I'll ignore this. And I'll close my drawing recovering manager. So what this does, if I go into model space, is it gives me this floor plan of the entire building, and I can take that and I can import it into Revit, or I can even just have it as a reference for as I build something out from scratch in Revit. So this is going to be a really great resource to help us with our in-class assignments as well as our homework assignment. So for the rest of this class session, because technically we have, about 40 minutes of class left, wink, wink. What I'd like for you to do is kind of a couple things. One, come into Revit, explore this sample file, delete things and see what it does. So I clicked on that roof and I deleted it. And oh no, this error popped up. and I'll just say, whatever, just delete that. I'm just going to play around with it and just see what it does, because ultimately this is a sample file that I can't mess up. And then I'll just close Revit, and when it asks me, do I want to save changes to the sample, I'll say no, because I don't want to mess anything up with that sample file. So just look at that sample, play around with it. And then the next thing that I'd like you to do too is look at the different house plans available through the Passive Solar Handbook. Download the plans for the Cardinal. So again, that's click on Download Plans. And then you're going to come up here to download them. And then you'll want to just save those onto your flash drive or onto your laptop's desktop, wherever you're going to be saving all of your stuff. So that way you have these ready to go for our next class session. And I'll just go back and look at some of the plans for the other ones and pick one out that you're going to do for your homework. So we're doing the Cardinal together in class. You're going to pick out another one to do for homework. And of course, if you have any questions or need any help, please feel free to send me an email or stop by my office, and I'd be happy to help with you. And we'll get started then actually making something in Revit together in our next class.